Australian rules football, or known as AFL, is a contact sport that is played by two teams of 18 on a field the shape of an oval. AFL is seen across the world as a high intensity and fast played game. Through the data collected from my game of Australian rules football, it is evident that I am an effective player as I am predominantly working within the aerobic zone, which is 70 to 80% of maximum heart rate, MHR. Through analyzing my heart rate data, it is also apparent the energy supplied to my body is via the three systems of the ATPC system, the lactic acid system, and the aerobic system, KISS 2010. Energy is produced from the breakdown of adenosine triphosphate, ATP, and creatine phosphate to adenosine diphosphate, ADP, in the mitochondria, KISS 2010. Throughout this presentation, I will be outlining how the three energy systems function throughout my game of Aussie Rules. Then I will be discussing how my target heart rate zones and the data I have recorded from my game of Aussie Rules, and how they are effective. And finally, I will be discussing the recommendations on how to be a more effective player.
The first system is the creatine phosphate system, which rapidly produces energy through the separation of ATP and creatine phosphate to form adenosine disphosphate, ADP. The formation of ADP releases energy for muscle contraction. However, this system is limited in the supply of creatine phosphate and therefore is only used to supply a small duration of exercise for up to 10 seconds as it is used in the absence of oxygen. If I was to stop or lower the intensity of exercise, the demand for ATP would be low and I would allow my creatine phosphate levels to be replenished. However, as I continue to conduct high-intensity exercise beyond 10 seconds, this means my lactic acid system has now taken over. The lactic acid system supplies ATP to my muscles when I am conducting high-intensity exercise through my glycolysis and carbohydrate stores. This system converts glycogen into glucose, then into pyruvic acid, which is known as the anaerobic glycolysis, as it is conducted in the absence of oxygen. This system is only sufficient for up to 1 minute as my body's stores of oxygen supplies increases. This is called the aerobic system. This system utilizes the use of carbohydrates and fats as the primary fuel, however, is used in the presence of oxygen. As Mesdros states, the food joules are broken down into the mitochondria, or otherwise known as the powerhouse, to produce energy to resynthesis ATP aerobically. This system is predominantly used throughout my game of AFL as I am only exercising for approximately 15 minutes and my aerobic system can last up to 3 hours. This system, however, increases the demands placed on my cardiorespiratory system to sufficiently deliver oxygen to my muscles as the required oxygen intake increases as the intensity of the game increases. Through analyzing my heart rate data recorded throughout the 15 minutes of gameplay shows I am an effective player as I am predominantly working within the 70% of my maximum heart rate. This method is calculated through Craven's method, which minuses my resting heart rate from my maximum heart rate and the target heart rate zone I wish to work in. This is represented in this table. It was recorded that my maximum heart rate in the game of AFL is 176 beats per minute, which is 29 beats per minute under my maximum heart rate. It was also noted that my heart rate dropped to 64 beats per minute, which is 2 beats per minute above my resting heart rate. My recorded data also represents that 36% out of my gameplay I am working within my aerobic system, and 15% within the anaerobic and red line zone. The 15% in the red line zone is supported by the graph representing my speed over time. As at points, I reach max speeds between 18 to 22 km per hour, and this causes my heart rate to increase correspondingly. This data indicates that I am running or attacking with the ball. It is shown after the small bursts in which my speed increases, it also decreases, therefore allowing my energy system to replenish my ATP stores. From approximately 6 minutes into the finish time of 15 minutes, my heart rate is fairly steady at an average of 165 beats per minute. This data represents the gameplay as before the 6-minute mark, my heart rate is fairly low around the 100 beats per minute, which is considerably low for the recommended target warm-up heart rate.
Owen Anderson has a PhD in sports science. He states, by gradually raising your heart rate allows your body to minimize stress on your heart during the early stages, but also allows your blood vessels in your heart to warm up and dilate, ensuring they are supplied with enough oxygen and are at their optimal temperature for flexibility, efficiency, and contraction. However, it is also recommended that the target heart rate zone I should aim for in my warm-up is around 50%. Therefore, my warm-up phase has shown to be ineffective as I have not allowed muscles to be warmed up, and therefore I will have had an effect on the beginning of my performance. Following my warm-up, it is seen in the graph representing my speed that I come to a complete stop for 1 minute, and this allows my ATP stores to be replenished. However, this was not long enough for my ATP to be replenished effectively. The other drops in my heart rate graph indicates that the times I may have not been near the ball, and this is supported by the speed graph showing there were many times where I wasn't running as fast and therefore causing my heart rate to drop. Through analysing my data, it is justified I was an effective Aussie rules player as I predominantly played in the middle section, therefore my heart rate in comparison with my pace graph shows I was consistently moving and my heart rate was kept constant around the aerobic to anaerobic threshold. In future, it is recommended that I undergo a proper warm-up where I aim to allow my heart rate to reach 50% of my maximum heart rate, therefore allowing my body to prepare for my game. I can do this by completing a 5 times 20 meter sprint set at 50 to 100% of my maximum heart rate. Therefore, I will increase my heart rate. It is also recommended I allow more time in between my warm-up and my game so my ATP levels can be restored and replenished efficiently. The recommended time in between a game by KISS in 2010 is 2 minutes. It is also recommended that I undergo more training in which I aim to consistently work within my aerobic heart rate zone and pushing into my anaerobic threshold and red line zone more frequently. Therefore, in games, I will be able to withstand the demands my cardiorespiratory system will undergo to improve my performance more. Training exercises should include cardio, HIIT, circuit, and interval training. Examples of these would be a 10-kilometer run, a 10-minute row with a 1-minute break period and repeated 3 times. This will increase my heart rate. These exercises will overall improve my performance as it will increase my aerobic capacity and therefore pushing my body to be able to work more predominantly within the recommended anaerobic threshold. In conclusion, through analysing my data recorded from my Aussie Rules game, I am an effective player as I reach my target heart rate zones for majority of my game. Through understanding energy systems, I was able to understand the various concepts in why my heart rate may have dropped or increased. Through this understanding, I was also able to portray that I need to allow for more time to replenish my ATP stores and am able to work towards increasing my heart rate throughout my game to move up into the anaerobic threshold zone more frequently.